Okay, so here you can see our oil and water mixture, and you can see the red food coloring that I added to the bottom. Now I'm going to add an Alka-Seltzer tablet. I'm just going to drop it in, and then we're going to watch the reaction. You can see the Alka-Seltzer tablet got coated in oil. Now it's starting to bubble. Okay, so now what I want you to think about is the Alka-Seltzer is causing what kind of change? And the oil and water mixing, is that a physical change, a chemical change? Neither. And I also want you to listen. Okay, we're going to add another tablet real quick. Okay, so as the Alka-Seltzer bubbles, it's releasing carbon dioxide. That works its way up through the oil. The carbon dioxide bubble gets to the top. That's what you hear sizzling. And the water that it carries with it, the red water, sinks back down because the water is more dense than the oil that it's floating in. And then you can see the tablet just ran to the top. Now, all mixed in, you can see the water layer at the bottom, and then mixed into the oil, you see all the little red spots. Those will all eventually sink because each little bubble is filled with water, and water has a different density than oil. Okay, so as there's less and less Alka-Seltzer in the water, as there's less Alka-Seltzer in the water, you can see the oil and the water layers separating. You can see the red water layer settling to the bottom, and none of the food coloring colored the oil. The oil stayed essentially yellow. The food coloring and the water are more dense than the oil, so they're settling to the bottom. And you can see the two different solutions separating. Okay, here's our final shot. You can see now that for the most part the water has all settled down to the bottom and the oil has all gone back to the top. The water's now completely red and the oil has stayed yellow.